Today's daily Leetcode problem of the day is the number of smallest unoccupied chair, number 1942. For this problem, there is a party with an n amount of friends, numbered from 0 to n minus 1. There is an infinite number of chairs at this party that are all numbered from 0 to infinity, and when a friend arrives at the party, they can sit on one of the unoccupied chairs with the smallest number. So chairs 0, 1, and 5 are currently occupied. When a new friend comes to the party, they will have to sit on chair number 2, because that's the smallest unoccupied chair. When a friend leaves the party, their chair becomes unoccupied at the moment they leave, so if a friend arrives at the same exact time, they can sit in the chair. We're given a 0 index 2D array times, where times of I is equal to arrival and leaving, and this indicates the arrival and leaving time of the ith friend, respectively. And an integer target friend. So target friend is the friend that we want to find what chair he's going to be sitting in. So all the arrival times are distinct, so they're all different. And the chair number of our target friend is what we're looking for. In the case where each chair becomes unoccupied the moment they leave, this simply means if a friend is leaving at time 4 and somebody's arriving at time 4, they can take this chair. So, for example 1, we have a friend that arrives at 1, leaves at 4, arrives at 2, leaves at 3, and arrives at 4 and leaves at 6. We want to find which seat friend 1 is going to be sitting in. So 0, 1. So friend 0 arrives at time 1 and sits on chair 0. Friend 1 arrives at time 2 and sits on chair 1. So we can see that here. That's really easy. So since he sat on chair 1, we can simply return 1. So target friend 0, this one's easy as well. So friend 1 arrives first, friend 2 arrives second, and friend 3 arrives third. So chair 0 is taken, chair 1's taken, he's going to have to sit on chair 2. So for this problem, we're most likely going to want to sort our friends by their arrival time because they're out of order currently. So we're going to want to sort them by arrival time, which would make this our first friend, this our second friend, this our third friend, making it easier to calculate which seat he's going to take. So we're first going to process and calculate sorting each of our friends in order. We will then keep a priority queue for when they leave. So we'll add 5 to the queue, add 6 to the queue, and then add 10 to the queue, and 5 is the highest priority, then 6, then 10. So we can first initialize our priority queue, then get the arrival time of our target friend, sort all the times to our arrival times, then initialize a next chair variable to track the next available chair starting from 0. We will create a set of available chairs to keep track of all the chairs that have become available, so all the friends that have left, and then we'll iterate through each entry in times. So let's first initialize our priority queue. So we have a priority queue, and it's going to have integer arrays. The reason we're going to be using integer arrays is we are going to store our arrival and leaving time so we can find which chairs are available. So this is going to be our leaving queue, which is going to be a new priority queue. We then can initialize our target arrival time, so it's going to be our target friend, so integer target arrival is going to be equal to our times of target friend of 0. So we're simply just getting our target friend's arrival time. We then can get our chair tracking set up, so int next chair is going to be equal to 0. And then we can initiate a tree set to track the available chairs, so tree set. The reason we're using a tree set is a tree set organizes and sorts all of our numbers beforehand. So tree set integer, and this is going to be our available chairs, which is a new tree set. So we have a priority queue to track when people are leaving. We have our target arrival time, which is when our target friend shows up. We have the next chair, which is going to track which chair is next on the list if none are already available. And our tree set, which is tracking the currently available chairs because friends left. Then we are going to sort our times by the arrival time. So we could go ahead and go up here and do this, so that way when we find our target friend and everything's in order. So we have our arrays.sort, and we're going to sort our times by a custom sorter. So we're going to sort A and B using A of 0 minus B of 0. So we're looking for which one is greater, and we're going to sort it based on that. So we're going to sort from smallest arrival time to greatest arrival time. So this is all of our initialized variables. We're sorting our times by arrival time. We have a priority queue that keeps track of when people are leaving. Our target arrival time is when our target friend arrives. We are keeping track of what chair is available and which friends are leaving, so which chairs are available. We are now going to go iterate through our times, and as we're doing that, we're going to extract the arrival and leave time for each friend. So we're going to free up chairs based on the current arrival time, and then while there are chairs in our leaving queue that have a leave time less than or equal to our current arrival time, we'll insert those chairs into our available chairs set, and then we can remove the chair from the leaving queue. We will then determine if the current chair is for the friend, if it's going to come from our available chairs set, or if there's no chairs, we will pull from our next chair variable. We can then push the current leave time and chair onto our leaving queue, and if the arrival time of the current friend matches the target arrival, then we can return our current chair. So this is going to be all in our for loop. So for each integer array time in our times integer arrays, we're going to have our arrival time, which is equal to time of 0, and we're going to have our leave time, which is going to be equal to the time of 1. So we're getting the times of A and times of B, and we're simply putting it into our variables here. We're then going to free up chairs based on the current time. So while our leaving queue is not empty, so leaving queue is not empty, and our leaving queue dot peak of 0, remember because we're storing arrays in the queue as well, is less than or equal to our arrival time. So we're basically just checking to make sure that whatever's at the top of the queue is less than the current arrival time, which means this chair is going to be open. Then we can available chairs dot add leaving queue dot pull. So we're basically checking if our queue is empty. If it's not, and our leaving queue dot peak time, so the leaving time is smaller than our arrival time, then the chair is now available. So we will add that to our available chairs pull, or our available chairs set. After that, we can initialize another variable, our current chair. So if our available chairs is empty, So no chairs have been added to the available chairs, whether that's because no friends have left or this is our first friend arriving. Our current chair is going to be equal to our... So, I mean, this does have elements in it. So our current chair is going to be the smallest element in available chairs. So it's going to be equal to available chairs dot first. So whatever the first element is. And then we can remove that from our available chairs. So available chairs dot remove the current chair. So we use that chair, we removed it from the set. Otherwise, our current chair is going to be equal to the next available chair, and we will increment our next available chair. Now, we're going to push the time in the chair onto the leaving queue stack so we can keep track of what chair will be available when. So leaving queue dot offer new integer array, which is going to consist of our leave time and our current chair. And then we're going to check if it's our target friend, because then we'll know if he's at the right chair. So if arrival is equal to target arrival, then we can return current chair. If we don't find the right chair, we can return 0. And I almost forgot, but we need to add our comparator for our priority queue because it's sorting integer arrays. So we're going to have A, B as what we enter, and we want to compare those by subtracting A of 0, so the arrival time minus the other arrival time, ordering them from least to greatest. So now if we run this, that passes our test cases, and if we submit it, that passes all solutions. So thank you, and follow for more daily LeetCode solutions.